Homework sheet U9 question 7. Here we've got a pair of parametric equations and we need to find an expression for dy dx in terms of t. To do that we need to start by finding dx dt and dy dt. dx dt is equal to 4 cos t plus pi by 6. This is an application of the chain rule. Sin u differentiates to cos u and we times it by the differential of the bracket, which in this case is just 1. dy dt is equal to negative 6 sine 2t. It's because cos u differentiates to minus sine u, and in this case the differential of 2t is 2, which is what we get when which we then have to multiply by the 3 to get minus 6 on the outside. dy dx is equal to dy dt divided by dx dt, which is minus 6 sine 2t divided by 4 cos t plus pi by 6. I can simplify this by dividing top and bottom by 2. If my denominator was in terms of cos t rather than cos t plus pi by 6, I would be trying to expand sine 2t and find things to cancel, but without that there's no reason to do so. In part B, I need to find the coordinates of all the points on C where dy dx is equal to 0. I've set my value of dy dx equal to 0. Only the numerator needs to be set equal to 0 for this to work, so I need to solve the equation sine 2t is equal to 0. 2t is equal to the inverse sine of 0, which is 0, or pi, or 2 pi, or 3 pi. Which means that t itself is equal to 0, pi by 2, pi, or 3 pi by 2. I now need to plug these 4 different values of t into my equations for x and into my equations for y. At t equals 0, x is equal to 4 sine pi by 6, which is equal to 2. Y is equal to 3 cos 0, which is equal to 3. So that gives me the coordinate 2, 3. At t equals pi by 2, x is equal to 4 sine 2 pi by 3. That's what you get when you add pi by 6 to pi by 2. That gives me 2 root 3. Y is equal to 3 cos pi, which is equal to minus 3. So I've got coordinates 2 root 3 minus 3. When t is equal to pi, x is equal to 4 sine 7 pi by 6, and that's equal to minus 2. Y is equal to 3 cos 2 pi, which is equal to 3. And finally, when t is equal to 3 pi by 2, x is equal to 4 sine 5 pi by 3, which is equal to minus 2 root 3. Y is equal to 3 cos 3 pi, which is equal to minus 3. So my final coordinate is minus 2 root 3 minus 3.